Here is one of them, as a matter of fact. She is currently a freshman nursing student, and I went ahead and laminated it so I could keep it and be able to show other students. Plus, I have two others. The idea, if you haven't looked at that homework yet, McGraw-Hill, it's our theory, McGraw-Hill needs a new figure. So you will see as we go through this chapter, as we go through this lecture, and you look at your book, you see that there are figures that talk about the somatic and visceral motor system. But they're not complete. None of them are complete. By complete, I mean we don't have where those neurons originate from, how much myelin do they have, are they short, are they long, what neurotransmitter do they put out, what receptor is there, and then how does the tissue respond, what are the target tissues, how do they respond, is it excitatory, inhibitory? There is no figure that puts it all together. So that's your challenge for this homework, is to come up with figure or figures if you need to, that bring it all together. And this particular person, a little artistic, so she went with, you know, lovely drawings. Another student took one of the figures that I'm going to show you today, and she just added the additional stuff to the figure. So even if you're just replicating a figure, you're learning in the process. This student liked to do tables. So this is what she did instead, and I reviewed this table before she turned in the final version. It took me a little bit to figure out the table, to make sure that it was all in there, and it was all correct, and it all is. It's just, it took a little bit of, okay, I get it. So we pass around these three examples while we're going through class to give you an idea. Alright, so we got that far, and we did that. We talked about the somatic, but we haven't really, did we really go over this slide? I had to get you through the sympathetic to explain the lab, but I don't know that I really went over the slides. Oh, no. We needed to have written more. All right, well, let's just make sure. Let's just go ahead and get started on it then, just to be sure that we've got it all covered. All right, we are talking about the motor division. That's what we're doing. So just remind you of homeostasis. We had a sensor, and that was an afferent pathway. Sends a message to the integrator, which sends a message, efferent pathway, to an effector. And of course, there is the feedback loop. So now we're in the nervous system. We've covered the sensor component, both somatic and visceral. We've now covered the integrator, in this case was the central nervous system. Now we're ready to talk about the effectors. So the effectors are going to be the motor system, which this is sensory. And then the motor system is divided into somatic and visceral. Somatic, skeletal muscle. Visceral, smooth muscle, cardiac muscle, and glands. Now what I don't want you to lose sight of, and it's easy to do, it's easy to lose sight of the forest, because we're going to be talking about the veins in the leaves of the trees. So you're going to lose sight of the forest. The forest is that this is all motor neurons. These are the effectors. Just motor neurons, effectors. Got to keep that clear. The targets between the two, somatic is skeletal muscle. Visceral is smooth muscle, cardiac muscle, glands. Why do I keep repeating it? Because students miss it on the test. Because you just get overwhelmed on the test, of course. It's just
Somatic is
skeletal only. And then visceral is going to be smooth muscle, cardiac muscle, glands. Again, so these are the effectors that are carrying out the wishes of the brain and the spinal cord. Okay, reminding you we're at the spinal cord. Reminding you of this, the cross section of how these neurons are coming in and out. We've already talked about the dorsal horn, which has somatic sensory and visceral sensory. Information's coming in along the spinal nerves, taking the dorsal root. There's the dorsal ganglia, collection of cell bodies for the sensory neurons, coming into the dorsal horn. But now we're ready to talk about just motor. The board's on. I'm trying to make sure the board's on, and then I can just touch it instead of having to lean over. So now we're talking about motor, which is somatic motor, which is in the ventral horn, and visceral motor, which is in the lateral horn. These are, now remember, they're coming from the brain. Do it on three-dimensional. Picture that. They're coming from the brain, synapse in here. Now here is the neurons leaving the spinal cord. So now these are going to be nerves instead of tracts, going from the ventral or the lateral horns along the ventral root of the spinal nerves and getting onto the spinal nerve and going out to skeletal muscle if it's somatic, smooth muscle, cardiac muscle glands if it's visceral. So soma means body, so somatic means just skeletal muscle. And then the visceral, it gets called autonomic because it acts without your will. You do not control your heart rate. You do not control your blood pressure. You are not controlling insulin secretion from your pancreas. These things are going on without your conscious control. So they are unconscious. And in fact, a lot of the smooth muscle and cardiac muscle, they contract on their own. They don't even need a nervous system for that matter. They do their own contracting. The autonomic nervous system just modulates how fast or how much. So both, again, they're motor neurons. Now this is helping you remember, this is homework 7. So it is a motor neuron. It's coming out of the ventral horn of the spinal cord. It is heavily myelinated as it makes its way to the skeletal muscle, and it's long. It's a very long neuron. Think about that. In order to get my toes to flex, that one neuron is coming from the sacrum, so that's really long. And it's heavily myelinated for rapid conduction. The visceral motor neurons, though, they're a little different. There's 2 neurons. So one goes from the spinal cord to the ganglia. I just remembered that, oh, and I don't have a, oh, but the lab's standing open. See, I left my office keys, too, in the chaos. The people from Denmark were getting ready to leave. They were loading up on the bus. The ones that are going to Denmark this morning. So I had to go over and say goodbye and bon voyage and all that. And so I forgot my office keys, too. I'll have to go get the prop that I need. There's a model that Dr. Collins has bought. So there's a neuron going from the spinal cord to a collection of cell bodies, the ganglia. It's lightly myelinated. And then that second neuron is going from the ganglia out to these targets. And it's not myelinated at all because frequently it invades the target tissue.